We're going to continue talking about logs today. 4.4 is properties of logarithms. The first thing we're going to look at is the change of base formula. The change of base formula takes the log of the argument and divides it by log of the base. So log of x divided by log of b. Now you can use the common log or you can use the natural log. So natural log of x divided by natural log of b. Either one, the important thing to remember is that the base goes on the bottom. So whatever this base number is in the denominator. So we use the change of base to evaluate a logarithm. So let's take a look at this first one here. We have log of 11 base 3. So we're going to take log of 11 and divide it by the log of 3. And then we can use our calculator to find out what that is approximately. And we get 2.18. All right, so try this next one. You can hit pause and then try it and then come back and check and see if you got it right. This one we should have log of 3 divided by log of 11. Notice that the base is on the bottom. And when we put it in our calculators, we get 0.46. All right, let's take a look at some properties. The first one, when we have two logs with the same base being added together, we can condense that down to a single log, still with a base of b, and multiply the numbers inside, x times y. Similarly, if you have two logs being subtracted that have the same base, you can condense that down to a single log, still has the base of b, and we are dividing those arguments, x divided by y. Property C, when you have log of a to the x, we can take that exponent and move it in front so that it's being multiplied times the log. So x times log of a, still with a base of b. So we're going to use those properties to help us condense. If you need more time to write them down, just hit pause. So we are going to look at log of 8 plus log of 3. They both have the same base, which isn't written here because it's the common log, so they have a base of 10. But since they're being added, we would multiply. So log of 8 times the log of 3. I'm sorry, not log of 3, just log of 8 times 3, which gives us the log of 24. And if we wanted to find an approximation for that, we could. We could put that in our calculator. Same rules apply when you're using the natural logs. So here we have subtraction. We talked earlier that subtraction means division. So 16 divided by 2. We still have the natural log of 6 being added. 16 divided by 2 is, of course, 8. So 8 plus natural log of 6. And then, since those are being added, we can multiply them. So natural log of 8 times 6, which simplifies to the natural log of 48. All right, number 5 has a lot of things going on. We have numbers in front. These coefficients are going to become exponents. So 4 is going to become an exponent on the 2. The 6 is going to become an exponent on the x. And the 1/2 is going to become an exponent on the y. So this is log of 2 to the 4th, base 3, plus log of x to the 6th, base 3, minus log of y to the 1/2. All right, 2 to the 4th is 16, and then since they're being added, we're going to multiply it to the x to the 6th. Still has a base of 3. Minus log of y to the 1/2. That's the same thing as square root of y. That's the more common way to write it. And since these are being subtracted, that means we're going to divide. So we have log, and then 16x to the 6 is in the numerator, divided by square root of y in the denominator, all still with a base of 3. All right, next up, Log of x plus 3 plus log of x minus 2. We see this addition sign, which means multiply. So we have log of x plus 3 still in the parentheses times x minus 2. And then we can FOIL those or multiply them. So log of x squared plus x minus 6 after we get it all multiplied out and simplified. Again, that log didn't have a base, so we know it has a base of 10. All right, here subtraction means dividing. So we have log of x squared minus 9 divided by x plus 3. Some of you might have recognized that that x squared minus 9 can be factored. So x squared minus 9 is x plus 3 times x minus 3 all over x plus 3. And then we can see that the x plus 3's can divide out. Those equal 1. So we have log of, keep it in parentheses, x minus 3. All right, next thing we're going to do is do it the opposite way. I'm going to give you a condensed version, and I want you to expand it out using those properties. So here we have x to the third, y to the second, they're being multiplied. So since they're being multiplied together, we can separate them with addition. So log of x cubed plus log of y squared. And then those exponents come to the front. So 3 log x plus 2 log y. On number 9, they're being divided. So dividing is subtraction. So we have log of square root of x minus log of y squared. And again, we bring the exponents to the front. Don't forget that the square root is an exponent. So that's to the 1/2 power. So we have to bring that to the front. 1/2 log x minus 2 log y. Now this last one has lots of stuff to do. Might hit pause, give it a try, and then come back and see if you got it right. All right, so our top stuff, we are multiplying. So we're gonna take the natural log of 3x and add it to the natural log of y to the 5th, because with addition is what we use when we're multiplying. But then we're dividing by this. So dividing is subtraction. So we have a natural log of the 4th root of z. And then we move all of those coefficients to the, or all those exponents to be a coefficient in the front. This would be an exponent of 1/3. So we have 1/3 natural log x plus 5 natural log y minus 1/4 natural log z. Now this is only half of section 4.4. We're gonna have a 4.4 day 2 next. But that's all there is for the properties of logarithms.